Hi guys. A few months ago when I stayed in Austria, I had to, let's say, 2 videos offline. Those 2 videos have been the most misunderstood and misinterpreted videos on my channel. And they have been about TT earthing systems and the so-called all-in-one inverters, which are off-grid inverters which can use the grid as a bypass, and how you could use the dry contact of those to make a neutral to ground bond. So what's a TT earthing system? The TT earthing system is the second most common earthing system used globally. It is specifically used in rural areas. This is where the consumers are situated most far away from the transformer. And what's the importance? If somebody installs an solar system on his house and wants to interact still with the grid, what he has to take care. What needs to be considered in that case. What is the TT earthing system and why is it so tricky when it comes to install solar systems, especially which do interact with the grid? So in the TT earthing system we still have, as similar to any TN earthing, we have a transformer which does have, of course, grounding, and it does have a connection, a bond between its grounding and the neutral. This is providing the definition of the neutral wire, makes it zero potential, while all other outputs of the transformer are then phase wires. But then from the transformer there is only a 2-wire configuration to every of the users, which are symbolized here as 3 houses. Now comes the difference to a TN system like a TNC or TNS. When it comes to the building installation, we have also again neutral and phase coming into the house. But inside the house there is no more bonding of neutral and the house earthing. So this is clearly completely separated, and in case of faults, in case of leakages in the installation, the return, the fault currents cannot take a pass back via the wire to the transformer. They have to take a pass back via the grounding system of the house. So let's take a look here in our house number 3. We have our electrical appliance, and now let's say we have a leakage from our phase wire to the case here of this electrical appliance. Our fault currents will now take the way via the grounding system, earthing system, go to the rod and then go via the ground back to the transformers grounding rod here, and now the loop is again closed because the currents will then jump over to the neutral of the transformer via the bond there, and this can then trip protective devices in our house. We are always talking about impedances, that the impedance for this return current, which has to now take 2 grounding rods, which do have of course quite high resistance compared to, let's say, a return pass wire. these return currents are usually not capable to trip our normal line breakers, like the MCBs which you have in your distribution panel. They will require a special form of protection, and this is done by RCD, so-called RCDs. They would of course already trip much sooner. Instead of tens of amps, they only require milliamps of fault currents to trip the protective device. So why do we actually even have to do this? This is because of requirements in such earthing systems. Because in the TT systems, I told you, we have rural areas. Usually the consumers are quite far away from each other, and they can be far away from the power source, which is the transformer. And all those impedances, resistances of these wires, long distance wires, they're adding up, and it would then cause, the further away you are from the transformer, the requirements to trip your protective devices might not be fulfilled anymore, because those impedances will just be too high then. So whenever those requirements cannot be fulfilled, the earthing system will be downgraded to a TT configuration, and RCDs have to be used. Why can't we do some sort of a mixed setup? Let's say I can use TN for user number 1 and 2 maybe, and everything what's further away is just TT. So the house number 1, house number 2 would have a bond inside the distribution, and return currents could go via the wire, and just the other ones would go via the ground. Well, this is not possible, because we would then create parallel passes for the fault currents, which is also the problem when we are talking about installing now a solar system. So let's take our case here. Our house number 2 has installed a solar system on the roof, and we have a secondary power source, an inverter built in here. What is in general now the problem if we add a second power source? We want to be sure that every circuit in that installation is behaving the same way, no matter which power source is supplying the house. So that means if our grid supply is TT, we have a grounding situation, we have appliances which do have metal cases, we have a piping there, metal piping, everything is grounded. We want that all of the system, all of the protective environment is behaving exactly the same way, also when the power source is then switched over to the inverter. Usually an inverter will be an isolated power source by nature. So if you do not define which leg is phase, which leg would be neutral, by bonding that leg to the earth, it would just be floating around. So neutral and phase wires would be somewhere in between 0 and your maximum voltage. And this is something what does have advantages in certain situations, but not in house installations. There you always want to have defined which wire is neutral, which wire is phase. And so we have to, if we switch from one power source to the other, also take care that situation, if the inverter takes over into a sort of off-grid setup, then we need to bond ground and neutral, so that at the end everything works exactly similar in our distribution there as it would when the power comes from the grid. So all the RCDs have to work the same way, and also our line breakers should work exactly the same way as it would when the power comes from the grid. So now imagine someone is putting a bond into his distribution here between neutral and ground here, just to provide the inverter with grounding information, so it knows now, okay, this output wire is my neutral and the other one is. If this bond is permanent and the inverter is now again, the system now is again switching back to the grid supply, we would have created a neutral to ground bond as well for the grid. What would happen now if our house here further down the road does have the leakage? So now the fault currents of house number 3 here, in this case, would still leak into the grounding system. But instead that all of the fault current returns back to the transformer rod, now some current will also be picked up by the grounding rod of our second house here, and some current will then also flow back here via the neutral wire onto the wiring and return here back to the transformer also by wire. So this situation would not just be illegal in the TT system, it can be dangerous now for your installation if you are the owner of the solar system, because you would actually now pick up fault currents from your neighbor, which of course you don't want. You will have currents here. You could now actually also measure currents at your neutral to ground bond here, and that would also confuse you, because you would probably think there is some fault in your system. Why would you have otherwise fault currents on your neutral to ground bond? But in reality, that fault current is not yours. Parallel or multiple ground fault loops in this earthing configuration, it could cause unexpected system behavior, and not just for you, also for other users which are connected to this system. As I said, the TT earthing system is based on the usage of RCDs. This gives the utility provider the chance to have quite bad impedances on the network. So to trip a 30 milliamp RCD, it only requires less than around 500 ohms of impedance inside the earthing system, and this is typically always easy to achieve. It quite depends on soil composition, of course. The point when installing another power source in your house, which means we are using an inverter, is all about creating that neutral to ground bond, and not doing it when you are connected to the grid, and making one when the secondary power source is active. And this is also not about grid-tied inverters, because grid-tied inverters are just simply connected to the existing grid installation, so there is no disconnect from the grid in this case anyways. So in any case, if you're trying to install something like this by yourself, it's your duty to take care about this, that you do not create any kind of neutral and ground connections which would then be visible in the other grid setup from the transformer until the last consumers which is connected to that transformer. If you're talking now about all-in-one inverters or full hybrid inverters, they come with a AC in where you can connect your grid and then have a AC output. Internally, those devices, that equipment will already take care of isolating the grid when it comes to an off-grid operation. So we don't need to take care about this. But what we need to do is we have to provide somehow the neutral to ground bond when the inverter is switching modes. And how this is done is, of course, we have to use some sort of a relay or contactor, something like this here. So this is a DIN rail relay. The only thing you have to take care of is that it can handle the currents which your inverter will produce when it comes to a fault. So when something shortens, when you have a ground leakage, all that current will then flow over the relay contacts, of course. So what we need is, and this will typically only give the inverter to us, the information of in which mode it is in. And in the case of an all-in-one inverter, what we have there, or can use there, albeit a little bit limited, is a dry contact. And in the case of most full hybrid inverters, they are providing a signal which is telling that the inverter is now off-grid. And those signals can then be used to close or open our contactor relay. So if you have an all-in-one inverter like this one, the only contact this is providing is a so-called dry contact. But the dry contact does not necessarily tell anything about the mode or the state of where this inverter is right now connected. So if it's running from the battery, if it's off-grid, or if the so-called grid bypass is activated. The only thing a dry contact tells is the more or less state of charge of the battery. And the only mode where this would kind of be similar, that when the state of charge goes down below a certain level, the inverter would then automatically switch over to the grid, right, where it gets the power from. So the dry contact would equal like an off-grid, on-grid relay contact. This is typically only in the solar priority mode. So where it tells where solar and battery is available, it will be off-grid, and when the battery is depleted, solar not available, it will then switch over to the grid, and this information can then be taken from the dry contact and then created a neutral to ground bond, which will be somewhere in your distribution then. When you're using the dry contact of an all-in-one inverter, then you have to study this table here. It's about the dry contact signal. You will find this in the manual which is provided to your inverter. And here you can then see the state of the relay of the dry contact depending on the modes. And when you study this carefully, you will then come to the conclusion that actually only the solar first mode would behave similarly to a sort of on-grid, off-grid situational contact. Still, this is not covering 100% of cases, because this would only work when the inverter is in a normal operating state. If the inverter is powering off by some faults or even losing power completely, then typically that contact could go into the different state into the opposite one as we need. But such cases are extremely rare. In my situation here on my all-in-one inverter, I actually never had a downtime of the inverter where it went out of the mode. Yeah, so better than the all-in-one inverters is of course something like this here. This is a full hybrid inverter, and instead of having an information, a contact which tells state of charge of battery, this is a contact which tells if it's off-grid or on-grid. So you can take that information directly to connect a relay which you can build into your distribution, and this would be then the output of the inverter. And if there's a relay inside there which is then taking care of a neutral to ground bond, then you can also use the TT system easily. I have shown that video already about the installation of this inverter, and there you can see how I am testing and showing what the inverter and the output, how the RCD works, if you bond or not bond, if the inverter is in the isolated mode or in a grounded mode, how that would then look like, and I will link the video above. If you like the video, press the like button. Please leave your comments and subscribe to the channel. I see you next time.